When we talk about an object having an overall negative charge, we mean that it has too many electrons. And when we talk about an object having an overall positive charge, we mean it's missing free electrons. This imbalance can be created and resolved in lots of different ways.
Say you have a glass rod that's electrically neutral and you rub it with a cloth. The physical interaction causes electrons to hop onto the cloth, leaving the rod with an overall positive charge. This is called charging by friction. Both the cloth and the rod began with a neutral charge, but after friction, the rod has net positive charge.
But whenever the rod ends up with a net positive or negative charge depends on the materials that you use, the ancient Greeks actually rubbed for against amber and discovered that the amber would then attract hair and feathers. Today, we understand that the force stole electrons during the process, giving the amber an overall positive charge just like the glass rod. Now, it's important to note that no new charge were created during this process. The overall charge between the two objects is still zero. Electric forces are used to bring power to your home, charge your computer, and light up the screen that you're using to watch this video. So, I want to describe complex situation involving charged particles using more than just Coulomb's law.
If we have an object with a known amount of net charge, can we predict how other electric charge will react when they pass nearby? A British scientist, Michael Faraday, came up with a way to do just that.
He hypothesized that every charged object generates an electric field that permits space and exerts a force on all charged particles it encounters.
An electric field is a measurable effect generated by an charged object.
A field carries energy and passes it on to other charged materials by exerting electric forces, and we can get to know how electric fields work in a couple of different ways.
Now, when we express the equation, the electric field created by a charged object is the electric force between the objects and the test charge divided by the magnitude of the test charge. To find F, you just have to use Coulomb's law, and you only need to know the value for big Q, the point charge. In fact, you can plug the equation for Coulomb's law into this equation in place of capital F. And if we do, you'll see the magnitude of the test charge cancels out and we're left with an expression that relies solely on big Q. Say we have one positively charged particle and one negatively charged particle that are some distance apart with an equal and opposite magnitude of charge. This pair of particles is known as an electric dipole.
When we talk about electric flux, it is defined as the amount of something as it passes through a particular region or area. This electric flux refers to the rate of the flow of the electric field, as determined by the number of electric field or flux lines passing through a given region. Example of this is turning on the light and the computer you type on. The generator somewhere in the grid most likely uses electric flux to produce the voltage you use, because it helps calculate the electric field for a given charge distribution enclosed by a closed surface.
I hope you learned. Thank you and God bless.